Sorry, and Grace, you have breaking news where you are.
Kuala Lumpur
Now, a line
dilanda
of
banjir.
Sekitar Muar dilanda banjir kilat.
Hai and Assalamualaikum warahmatullahi wabarakatuh. My name is MYCYS23 bin Kamal.
My name is Arzuhal bin Armazawi.
And my name is Ajus Hakimi bin Muhammad Fakrudin.
We are from FARIS PETRA Secondary School and we are now proudly to present to you our project, which is the instant flood wall. Flood is one of the most important part in hydrology studies and is very significant in civil engineering research. For the past couple of years, frequent unexpected flood that occur had caused tragical loss in terms of human lives and also commercial properties. As a deterrent to this particular issue, the usage of sandbags has been introduced, but it is not as effective as it should be. Therefore, an alternative mechanism known as the instant flood wall is developed to keep the flood water away from getting into the buildings.
The main purpose of this project is to overcome the disadvantages of the usage of sandbags. For example, a high amount of money is needed because a large amount of sandbags is required to build flood barriers. Secondly, sandbags are not able to efficiently block the water to enter an area because they can be easily broken down. Next, sandbags can cause pollution. This is because sand from the sandbags are released into the environment during heavy floods.
Firstly, we want to create design for the flood wall, which is applying the concept of hydrostatic force. Next, we want to fabricate a lab scale model to stimulate the flood wall system instantly. The third one and the last one, we want to make a better science-based product which is substituting the old style, which is using sandbags.
The first step for the instant flood wall is to plan the design of the instant flood wall and decide on the scale and size. Next, we will prepare the materials needed. Then, we have to build the prototype according to the prior design. After that, implant the flowing tubes below the danger level, then attach the instant flood wall with floats that act as a buoy, and finally, test the prototype with water. When the water from the river rises to the danger level, the water will flow into the flowing tubes since the position of the tubes is from a high level to a lower level. The gravitational potential energy of water will be converted into kinetic energy. Thus, the water will flow through the tubes with a high velocity. As the space under the flood wall is continuously filled with water, the water pressure in the space will increase. Then, a great hydrostatic force exerted at the bottom part of the wall will result in the rise of the flood wall. The floats attached to the flood wall uses the concept of buoyancy, hence decreasing the flood wall's weight and will make the flood wall rise smoothly.
Experiments have been conducted to test the effectiveness of the instant flood wall. This kind of process is to investigate the relationship between the high water level and the rising of the flood wall. We try to put a different volume of water to see whether the flood wall will rise up according to the speed of the water. It shows that when the water reaches the danger level, it is channeled by the underground flowing tubes. After that, the water fills the area under the wall, which is already attached with the float. The wall is successfully operating instantly when the water is starting to fill in the area. Then, a smooth movement of water is obtained. As the conclusion, the movement of the wall is directly proportional to the movement of the water under the float. This invention should be commercialized to the professional engineers outside there because it is beneficial not only to the people but also to the buildings for the agriculture and also to the engineering. As a justification, the project will save the money used to protect the aimed areas. Second, the flood wall will become a permanent protection compared to the temporary flood barriers which uses the sandbags. And third, it is also more effective as it will rise up according to the speed of the water and based on the pressure exerted under the wall.
So, we can conclude that the flood wall operates instantly due to the hydrostatic force exerted under the float of the wall. Next, a simple design of the lab scale model really proves its effectiveness. The third one, this project could help in blocking water from rising up in an area. And lastly, do not worry about the cost, but worry about the effects after the flood.